Hey guys, for calculus, this is coming from 2.1 from your textbooks, and for pre-cal, as we learn calculus, this is also coming from 2.1 from the material that we use. Okay, so we're going to start talking about derivatives in chapter 2. I'm going to remind you of the very first lesson that we did, the intro to calculus, how we talked about derivatives being a fancy word for slope and rate of change. In the past, we used slope for linear functions because the rate of change was consistent. The rise over run was always the same amount. But when functions start to have a curve, then we need a slope for every specific point, because here my rate of change is increasing, and then it's 0, and then it starts to go decreasing, negative. So our slope, our rate of change, is constantly changing on a curve. And that's where derivatives comes in, okay? So the first part of this video is going to be talking a lot about the word average, which is going to be going back to slope before we actually get into derivatives. So you're going to hear me say the word average rate of change, because if I say rate of change without the word average, then it talks about derivatives, okay? So let's start off. I try to color code as best as possible for you here. Let's say I measured, let's say I was on a boat and I measured where I was at this point in time. And then at this point in time, I cannot take the derivative, the actual rate of change that I was going, because it's definitely, like we said, different here. It's positive and here it's negative. But I could take the average rate of change that I was going throughout that time. Okay? So let's start off in black here. Slope we know as y2 minus y1 over x2 minus x1, right? That ordered pair compared to that ordered pair. In a fancier notation you started to learn later on in algebra, we said y could be said as f of x. So if this is x1, then this is f of x1, and if this is x2, this is f of x2, and then my slope formula looks like this. Okay, I'm just showing you different wordings. Now, the one that you're going to be seeing new, and you're going to be seeing quite often, is this one, okay? So if I call this point my initial x, right, and I travel some distance h, I can call this point that x value plus that quantity of h, okay? I put you this side note that sometimes textbooks, instead of using h, they use delta x. Delta means change, so they call h the change in your x, okay? So don't be surprised if you see delta x in other textbooks, and even if you go on into AP Cal, you'll see that notation sometimes as well. So now if this is x, in blue this is f of x, and if we call this x plus h, we can call this f, the function, at x plus h. So now my y2 becomes f of x plus h, my y1 becomes f of x, and then my denominator x2 is now x plus h, minus x1 is just x. Those two x's cancel, leaving me with this. All of these three scenarios, these two blue, this is just a cleanup version, the black, the green, and the blue, are all different ways of saying slope, average rate of change, and then you're also going to be seeing the word average velocity. So velocity, if you think of your car, is how fast you're going, okay, what your rate of change is. Maybe if you have like a Cuban grandmother, you've heard, ¿Qué velocidad fuiste? Like, she meant you were going fast, right? So your velocity, for example, if you're driving, you were going 60 miles an hour. Your change was that in 1 hour of time, you traveled 60 miles, okay? So that word velocity is going to come in hand a lot when we talk about slopes and rate of change. But when we want to use the slope scenario, you will hear that word average every time, okay? So let's go into some more details now and see how these questions can be asked, okay? So average rate of change, keyword is going to be average. You're going to be using the slope formula. And then you have two scenarios of how the questions can be asked, okay? So in both scenarios, they're going to give you a function. In scenario number 1, they're going to give you a domain, meaning they're going to give you two x's, okay? Your first job is going to be to plug each of those x's into the function to get your y's, okay? Once I have those x's that were given and my two y's, now I have two ordered pairs, and I can plug both of those ordered pairs into my slope function. And I'll get a number as my answer, and that will be the average rate of change that happened at that time, okay? Now, if one ordered pair is given, or one x value. And if that one x value is given, I can just plug it into the function to get the y value, and that'll give me my one ordered pair. I'm going to plug that in as my x1 and y1. Okay, so I'm only going to plug it into this right hand side of slope, and when I clean it, my answer is going to be a function. Okay, then I can plug in the x value into that new function, and that will give me the rate of change that is happening at that specific one point. Okay, so the difference here is we're talking about a range of places and what the average rate of change could be. And then the second scenario is us using average rate of change to actually be able to determine at one specific ordered pair what the slope was at that spot. Okay, so we're going to look at this first arrow as our first scenario. It says find the average rate of change of f of x. I should change that word to from. I'm going to pause really quick and change that word to from, because in interval we'll use the word from and not at. All right, I changed that word at from because that's my mistake. They'll use the word at when it's a point, and they'll use the word from when it's a range of numbers from here, -2, all the way up to 12, okay? So now, if it's average rate of change and they gave me a domain, my first step is going to be to plug those into my y's, right? So I need to figure out what y1 would be, which would be plugging the -2 into the function, which would be 3 times -2 squared. And I'd need to figure out what y2 is, which is plugging in 12 into the function, which would give me 3 times 12 squared. Okay? And that would give me, you can plug this into your calculator, 12 and 432. Okay? So now, if I want to know my average rate of change, I'm going to say slope, which is f of 12 minus f of -2 over 12 minus -2. Now, I know we already found these two numerator numbers, but especially for those of you that are thinking of AP Cal, this is proper notation to write that out. This is like on a free response question, how you show them proof that you understood that average rate of change meant slope. So don't skip the step of writing that. Okay, now you can say 432 minus 12 over 14, and this gives me 30. Okay, which again on an AP test, I'm going to start teaching you to stop here the day you take AP and not finish going all the way to the end, because you save time on a free response and you save the chance that you could make a little mistake there. Let's check out our next scenario. All right, this next question, I used a little bit of different vocabulary just so you can be exposed to it. I put find the average velocity, which means the exact same thing as find the average rate of change. Rate of change and velocity are synonyms, okay? So find the average velocity of the function x squared at x equals -2. So again, I know I had made the mistake last time, but notice on purpose I did use the word at here. This is now talking about a specific point. So step one here is going to be to find the y value of that point. So we're going to say the function at -2 is going to be -2 squared, which gives me 4. So that means that the ordered pair, that one single ordered pair, this is scenario number 2, that I'm working with is -2, 4. Right? Next step, according to these dots, is I'm going to plug that into my slope, but just as the right side, just as the x1 and the y1. So I'm going to say f of x minus f of -2 over x minus a -2. And again, I know that I already know what f of -2 is, but in an AP Cal test, this is how you get credit for understanding that vocabulary. So now my f of x is the function that was given initially. So f of x turns into x squared minus f of -2 is 4 over, I have x plus 2. Okay? Now, some notation that might be new to you is once I have this function, I know that my next step is going to be, see, I get an answer as a function. It's going to be to plug in that -2. In calculus, you start learning a notation, which is really nice. You put a bar, and you say x equals -2. That means your next step is to find this function at x equals -2. And now I can say -2 squared minus 4 over -2 plus 2. This gives me 4 minus 4 over 0, which is 0 over 0. Now, when we started learning limits, we know that 0 over 0 is an indeterminate. This is an error, okay? Which means that I have to try and clean up the function first, all right? So maybe some of you caught this earlier, and that's fantastic. That numerator, we talked about conjugate binomials when we reviewed Algebra 2. We have a squared minus a squared, so that can become x plus 2 times x minus 2, okay, over x plus 2. And you can see that these x plus 2's cancel out. So what I'm really working with now is the function x minus 2, and now I can plug in the -2, and I get -2 minus 2, which gives me -4. Now it worked. Now I got an actual number. Okay. All right, last thing for today. Something, I put a big red star there because this is something that in the AP test is very, very popular. And that is writing the equation of a tangent and secant line. So a tangent line has the same slope, and a secant line has the opposite reciprocal slope. So remember, m means slope, so that means I'm going to use the same slope that I would have had. And then secant, I'm going to use opposite means opposite sign, so I put a negative, and reciprocal means to flip the fraction. So if this was slope was like m over 1, this would be 1 over m. And then they'll give you an ordered pair of where to do the equation of a line with. And again, remember the equation of any line is y minus y1 equals the slope, tangent or secant, times x minus x1. So I'm going to use the two examples that we just did down here because we just finished finding their average rates of change, their average velocities, which we said those were synonyms for slope. So these down here are the answers of our slope. So I'm going to use 30 as a slope for example 1, and then I'm going to use -4 as the slope for example 2, okay? So if this question says find the equation of the tangent and secant line for examples 1 and 2, in example 1 we said my slope was 30, okay? So let's do tangent line first. An equation of the tangent line would be y minus, I have to go pick my ordered pair from example 1 to plug into that spot, equals my slope, which is 30, times x minus, I need to go back and find my x, okay? So for example 1, okay, we technically had two ordered pairs because they gave me a range of numbers. They gave me from -2 as my first x all the way to 12 as my second x, which means you have the freedom as writing the answer in two different ways. You can write the answer using -2, 12, or you can use 12, 432. So we said -2, 12. Or we said 12, 432, okay? So like if you were taking an AP exam, you would have the freedom to choose either of the two ordered pairs to plug into this spot here. My suggestion, so that your life is easier, is always pick the one with the smaller numbers, okay? But again, you could have two possible answers. So I could put my y1 here, and then my x1 in there, which don't feel like you need to isolate y. you can leave your answer just like this. I'm just going to clean up the two negatives. Okay. But just in case you did, I'm going to put an OR scenario. And I'm going to use this second ordered pair to show you what the other answer would look like. Okay. So this is for tangent line. If you were being asked for the secant line, all you would have to do is change your slope. Let me scroll back down. You'd put a negative and you would put 1 over 30. Using, again, either of the two ordered pairs. Okay, so this was the more complicated of the two, just because you had two ordered pairs and you had to do the work to find those y values. Oops, sorry about that. Okay, for example 2, it's going to be a little easier because you have that one ordered pair given to you since the very beginning. Okay. So in example 2, our slope was -4, and then they had given us the x value of -2, and we had found that the y value was 4. Okay. So if they were asking for tangent line, I don't have two options now, so I won't have an or for this one. I would say y minus my y1 equals, tangent line has the same slope, and then x minus my x1, which this will clean up to an x plus 2 at the end. Okay. And now for secant line, I would say y minus y1 equals, secant line has opposite, which means change the sign, so I'm going to have it as a positive, and reciprocal means flip the 4. So if it's 4 over 1, now it's 1 over 4. And then x minus the first x value. And again, I'm just going to clean that at the end. All right, for my calculus class, this concludes your 2.1. I apologize. For pre-cal, this concludes your 2.1. You will have a 2.2 video. For calculus, there will be a continuation video for your 2.1.